We're building up to a multi-agent research assistant that ties together all the modules of this course. And to build this, we've been discussing a few line graph controllability topics. We covered parallelization and subgraphs. Now we're going to talk a little bit about MapReduce. So, as before, we're going to use length width tracing. And let's kind of lay out what MapReduce is. So MapReduce is basically an efficient task decomposition and parallel processing method. And it has two phases. One is what we call map phase. So that is take some task, break it into a bunch of subtasks, and do them all in parallel. Then the reduce is basically aggregate the results from all those parallelized subtasks and bring them back together. That's the main intuition. So here's a toy example that we're going to kick off. In the map phase, we're going to create a set of jokes about some topic. Reduce phase, we'll pick the best one. It's a really simple toy example. So here we'll just set up a few prompts. We'll set up a prompt for generate a list of subjects related to some topic that the user provides. Then we're going to have a prompt, basically, hey, create a joke for each subject. And we'll have a third prompt, select the best one out of the list. Okay, so that's kind of the setup of the problem. Let's talk a little bit about state and kind of how we're going to lay this out. So subjects and best joke are just two schemas that we're going to use. And you'll see a little bit later why this is very useful. Basically, it's going to be used with our LLM to produce structured outputs that adhere to these schemas. One of them is going to be a list of subjects. One of them is going to be the ID or index of the best joke from the resulting list of overall jokes we've made. Now, the most important one that's interesting is this overall state. This will contain the topic provided by the user. It'll contain subjects, which is a list of subjects we'll produce using this schema. Now, this is really the one to watch. This jokes, you can see it has a reducer on it that will append to the list. And what's happening here is we're going to fan out or map to a bunch of nodes that will produce jokes, and they're all going to write to this same list. So this list is kind of going to be the aggregation for all of the individual map nodes, jokes, and then we can use that list later to select the best one. So let's talk through the individual pieces now. This is just generate topics. So we take in state, we will grab the topic from state, form a prompt from that, and run it with our model. And again, we're actually using this with structured outputs method, which is very convenient. It allows you to produce a structured output from an LLM. We talked about a bit about this previously. Adhering to a specified schema. So this subject schema we define up here, and it's just going to be a list of strings. So it basically constrains the output to be of a particular type, which is very important here because we want this response to be a list. So we can go ahead and run that. Cool. Now here is where we're going to do really all the work. We now have this subjects list that lives in state. Now this send API in LangGraph is really the magical piece here. So what's going to happen is we have this list in state. You can see subjects. Now all we need to do is iterate through that list. And for every element in that list, for every subject in that list, we can use send to send it to a particular node. And you can see we have this generate joke node, which we'll define in a little bit. It can take in that subject, and it can do some work on that subject. In particular here, it'll generate a joke. And you're going to see very briefly, we can write that back out to this jokes key, which can append to our list using this add reducer. So this send API is really convenient for at least two reasons. One is that this list can be arbitrarily long. So this could be any number of subjects, and it'll automatically spawn a generate joke node effectively for every element in that list and run generate joke. So that's one. It's very flexible in how many of these you can kind of spool up in your graph, which is really nice. We don't have to manually create all those edges. It'll automatically generate them all for us based upon the size of this list here of subjects. The other cool thing is we can pass arbitrary things in. So this subjects key is in the generate joke state, which we'll define very briefly. But that state can contain anything we want, and we can just simply plumb it in here. It's very flexible. It doesn't need to adhere to what we see here as the overall state. So this generate joke node that we're mapping to could have any state we want, and we can arbitrarily write to it in this via this send API. So let me show you that in particular. We're going to find that generate joke node right here, and it has its own joke state, right? In this case, it's only the subject, which we write to right here, but it could be anything, which is actually quite nice. So you can actually decouple the state of your mapped node from your overall graph state. And actually, we're going to be doing that when we kind of go and build our final assistant. Again, we're going to use structured outputs here. So basically, we're just going to have the LLM produce a joke, and it's just going to be a string based upon the prompt. The prompt is here. Again, we have that joke prompt, which we format with the subject that we pass. We get the joke, and we return it. Now, see something a little bit subtle here. We return jokes. We're writing this back out to our key here in the overall state, this jokes key. And again, we're passing it as a list so that it is indeed appended to our overall jokes list. That's it. So those are the key things to understand about the map step, which uses the send API here. And this is just the generate joke node that has its own state, and that will be duplicated arbitrarily via the send API, which is quite nice based upon the length of the list of subjects. Now, the reduce phase, best joke selection, is really simple. All we need to do now is we have jokes written to state now as a list from here, and we just join them all into a single list, single string, and we pass them to our best joke prompt. And again, we just asked an LLM to pick the best one. This will respond with the index, if you recall. The best joke schema here is just an int, indicating an index value. So this returns an index, and that's really it. We just index that jokes list with the ID of the best one. Very simple. And return it. So it's pretty nice. Now let's try to compile that and see what happens. There we go. So we generate our topics. This is a list. Now here's the send. No, this is actually very interesting. This dotted line indicates a conditional edge. So you can see we apply add conditional edge, generate topics, continue to jokes, goes to generate joke. Now this continue to jokes is defined right here. That's this edge that uses a send API. So this, again, sends from, as we defined it down here, generate topics to generate joke, and it'll spawn up some number of generate joke nodes based upon the length of the topics that we want to generate a joke for. So that's really the new piece to recognize here. This is effectively the map step. And then those all go to best joke. So best joke, like we just saw, receives that list of jokes that the map step produces, and it picks the best one. Updates the state with the best one, and that's what we get out. So we can see this all running. There it is. So we can see generate topics. There's a list of topics. Here is the jokes. And here's the best joke. So this is a great example to also look at in Langsmith. Now I have my Langsmith open. Here is this trace. And let's walk through it in step by step. First we ran generate topics. Let's look at that. So here's the generated topics: lion, elephant, dolphin, penguin, given the entry topic of animals. Now I can expand this, and I can see this continue to jokes. Remember, this is that conditional edge that contained the send API. Let's look at what happened here. So this is the key point. You pass in this list of subjects, and it creates, basically, a bunch of calls to the generate jokes node that pass each of the subjects from that list in. That is quite nice. So it automates that parallelization for us. Now we can see those 4 generate joke nodes run. That's great. And this is going to be kind of as you expect. It's basically just going to generate a joke about the topic passed in. Lion, it performs a tool call to structure the output according to what we specify as a joke, and it's just like a string. And we can see, each of these is kind of identically laid out with different topics. And then we have this best joke, which very simply we can look at the call here. Here is our prompt. Here's a bunch of jokes about animals. Here's the ID of the one it likes the best. And then the graph goes ahead and returns the joke ID 2 from this list as the best joke, and then we finish. So let's show this in Studio for one further illustration to really bring this home. So this is the same graph we've been working with. Pass in the topic, animals. Now we generate a list of subjects. That's cool. So let's just walk through it. Generate a list of subjects. Each subject, we run this map step, generate a joke for each one. Boom. So we have 4 jokes generated, 1 for each subject. That's great. And then this reduce phase goes and selects the best one. In this case, it selects one particular joke. So I can even rerun this, and let's pause it here. Okay, we'll create an interrupt. I'll create a new thread. Let's go back to my MapReduce graph. I'm adding an interrupt here. There it is. Animals. Generate topics. Now we're paused. Okay, so let's just look at this carefully. What's going on? We generate our subjects. Here's our 4 subjects. That send API automatically then spools up 4 different joke nodes, right? 1 for each of our subjects. And this is really nice. It does this all for us, right? We didn't actually draw this out in the graph. That send API takes care of it for us. Now let's just go continue. There we go. They all generate jokes in parallel, and that's very fast, obviously. And there we go. We go ahead and generate the best joke, picks the best one, and we end. So this is a nice way to kind of see MapReduce working visually, and I encourage you to play with it using mapreduce.py in the repository.